Hello everyone, my name is Isaac from the Innovation Consortium, and today I would like to share with you about pulleys, and specifically the V type of pulleys, because they are the most common type of pulleys we use in industries or even machines. So today specifically I would like to talk about the V type pulleys, their definition, the types, the different types, and what we use them for. So to start with, I'd like to give you a basic definition of what a pulley is. A pulley is just a circular wheel with a V groove, which is used to transmit motion, rotary motion, that is, from a drive shaft through a pulley or through the V belts to the driven side. So basically, to redefine it, it's just a circular wheel, as you can see it. It's a circular wheel with a V groove used to transmit rotary motion from a drive end to the driven end with the help of V belts. So basically that's the definition of a pulley. The different types of pulleys, or how you differentiate them. The difference in pulleys comes with the difference in materials, the difference in size, and the physical appearance. To start with elaborating, I will start with the material. Pulleys are made from various types of materials. Pulleys can be made from cast iron. Pulleys can be made from aluminium. Pulleys can be made from steel. Depending on the load and what they are to be driving, that's where we gauge or we find the different types of material in which we are supposed to make a pulley. So the different types, they could be cast iron, and cast iron is the most common type of material we use. There is aluminium, there is alloy steel, there is steel itself, mild steel, and very many different types of materials. To go on the other specification, or the other type, or the other difference in the pulleys, that is to be the difference in the size. And the difference in the size, we normally specify the difference in size. That's the diameter or the circumference, but basically it's the diameter. And the diameter on local markets, or the standard diameters, are measured in inches or in imperial dimensions. And I'm talking about inches. When I talk about imperial, I'm talking about inches. So the difference in the diameters is measured in inches. Take for instance, pulleys come from basically from 1.5 inches, and far on they can go even as far as 30 inches, 40 inches, 50 inches, and so on and so forth, depending on the load, on what they are driving basically. So with me here, I have the different types of pulleys, as you can see. But before I talk about the different types, I would like to briefly talk about the parts of a pulley, actually, to get a clear picture of what a pulley is. If we come across a component like this, the main parts of a pulley would be, the pulley has the face, and this is the face of the pulley you're seeing here. This is what we call the face. It has the hub. The hub is this middle part you're seeing here. It has the arms, and the arms are these, the members you're seeing crossing, joining the face, joining the upper part and the hub. So those are what we call the arms. And it has the bore basically. So it has the face which is comprising of the groove. It has the arm. This is what we call the arm. It has the hub, and it has the bore. So basically those are the main parts of the pulley. So going to the different types, after understanding the parts of the pulley, I will start with this specific one I'm holding here. This is called the V type, or the V pulley. Why it's called the V pulley? Because it's having the V groove. So specifically, that's why we call it a V type. If you're to look closely on the cross section of the groove, it's in the V form. So that's why we are calling it a V type. And in most cases, it's the most common type of pulley we use in the factory setup on our machines, as I will be explaining further on. We have another type of a pulley. It's also a V pulley actually, but it's a quadro pulley actually. Why a quadro? Because it's comprising of four V's. That's why we call it a quadro. Then we have a duplex V type. It's having 2. Then we have a triplex. It has 3. Then a quadruple. It has 4. Then this one particularly we call it a simplex because it has 1 groove. A simplex. Then we have a duplex. Then we have a triplex. I don't have it here, but for it, it has 3 grooves, and far on and so forth. So depending on the grooves the pulley is having, we derive the specification or the name of that specific type of pulley. Then the other specification, it would be the diameter, as I elaborated earlier on. And the diameter, if you are to measure the diameter from one edge to the other edge, the end of the pulley, we are getting the different types of diameters of the pulley. So the one I'm having here, if I'm to measure and you look closely, this one is a 3-inch. It's a 3-inch. Then duplex, because it has 2 grooves, 3-inch, then duplex pulley. The other specification will be about the type of the V, because they come in classes. There is a class A, a class B, and a class C, but I'll explain those ones later on. So this one, we are having a 3-inch duplex pulley. 3 inches, the diameter, then 2 grooves, making it a duplex pulley, 3-inch duplex pulley. Then the other specification, we shall add on the type of groove we are having, or the class of the groove we are having on this specific type of pulley, to fully define the pulley we are having actually. So the other pulley I'm having, it's called a stepped pulley. Why stepped? It's having grooves, but they are in a conical shape, and these ones are most commonly used to vary speeds or where variable speeds are applied. Take for instance like drilling machines and any other machines, so long as speeds vary depending on what you want. So it's called a stepped pulley. It's having V's also, but they differ in diameters. We are having a bigger one, a smaller to the smallest. So that's why we call it a stepped pulley. The other pulley I'm having, it's also a V type, but this one I wanted to show you the difference in the material. This one is made out of aluminum. It's light in weight, and basically it normally we apply it when we are driving low loads or slightly smaller loads compared to the other ones of cast iron and steel pulleys, the cast iron pulleys. So with aluminum, we are driving low loads, but again, that doesn't necessarily mean that the pulley is weak itself. Aluminum as a material, it's strong as a material property. So it's a pulley, it's made out of aluminum, drives low load, but it's strong as well. So you don't mistake it being aluminum, you consider it being weak. Aluminum as a material, it's normally strong. So we have the aluminum piece, we have the cast iron, This is what we call cast iron, as you can see. This is cast iron, this is aluminium, and the other steel. So they only differ in weight and where we are applying them. To talk about what pulleys are used for, pulleys basically, their main role or their main purpose is transfer the rotary motion from one drive end, as we defined it from the definition I gave at the start. It's their main purpose they serve in the production role. They transfer a rotary motion from a drive end, it could be a motor. With the help of the V-belts, they transfer a rotary motion from a drive end to the driven end. Take for instance, if I want to drive, be it a machine or a hauler, or it could be a silage machine, it could be a drilling machine, as you're seeing this component over here. So basically we have an engine. An engine could be a motor, it could be a diesel engine, it could be anything which produces power or a rotary motion. So we adapt a pulley to it, then the pulley rotates with the power source, that's the motor, then it transfers with the help of the V-belts, it transfers the rotary motion to the driven end. We can take a look maybe at the drilling machine so that we get a clear picture of how a pulley works, or it's the purpose it serves in transferring motion. Now if we are to take a physical view, or to know the purpose or the role of a pulley, how we use it and where it's used, as you can see, we have our drilling machine here. It has a motor. This is what we call a motor. The motor is having a shaft inside it, or a rotor. Now the rotor is having the pulley you're seeing here. This is the step pulley I talked of. It's having a pulley, another pulley, and another pulley. So it has one drive pulley, it has the idler, and it has the driven. So we are transferring motion from the motor to the spindle of the drilling machine. So when we need to transfer the motion from the motor to the spindle, that's where the pulleys come in from. With the help, remember we said with the help of the V-belts, that's how we transfer motion with the pulley from the drive end to the driven end. As you can see, we are having a drive end, we are having a pulley, it goes to the idler, it comes from the idler then to the driven end. So from the motor to the spindle, we are transferring the rotary motion from the motor to the spindle with the help of the pulleys actually. So right here we are going to take a clear view of how a pulley works and how it transfers the motion, or how it transmits the motion, the rotary motion, from the motor to the spindle of the drilling machine actually. So it's a bit risky, but for you to receive a clear picture, I'm going to try safely to show you how it works out actually. I'll be switching on and we'll be taking a clear look at the pulleys and the belts, and you'll notice the spindle running with the help of the pulleys actually. As you can see, the pulley is rotating with the help of a V-belt. It's rotating the idler, then the motion is transmitted to the spindle, as you can see. So basically that's how a pulley works. It adapts onto the motor, which is providing the drive, then it transmits with the help of the V-belts, transmits the motion to the spindle of the drilling machine. So basically that's how, that's the main role of a pulley. Now we can take the second look at the same pulleys we talked about. we're having a pulley here. This is a pulley, this is a pulley. So the drive, this is our drive, it's a motor. So the motor is the one to transmit the motion to the reducers or the gearing system. So ideally, we have a motor, then the motor, we have the V-belts, then from the V-belts, we are having the driven pulley. So to sum it up in a nutshell, it's just from the drive end to the V-belts, then to the driven end. So that's where pulleys work. That's how they transmit the motion, basically. So basically we are going to talk about the classification according to the size of the V or the groove, the classification of the groove of a specific pulley. And to start with, I'll mention the different classes or the different classes of the pulleys. We have a class A, we have a class B, class C and D, and those are the most common types of classes we use in the industries or even fabricating machines. So to talk about to clarify on the classes always define the sizes, class A, class B, C. So they go on increasing on the size depending on the class. Class A is smaller, class B is bigger, then class C is bigger than B, then D is the biggest on the 4 classes actually. So to know the specific dimensions of the different classes, we shall take a physical view or physical measurements on these different classes. We have a class A type of pulley, and the measurements of this class A from the top edge to the other top edge, it will be measuring 13 millimeters, and the depth will be measuring 11 millimeters, and the inclination angle will be 40 degrees. So for a class A pulley, to differentiate it with the other classes in the measurements, it will be from edge to edge, the top edge to edge, to measuring 13 millimeters. Then the depth will be 11 millimeters, sorry, it will be 9 millimeters, the depth. Then the inclination angle will be 40 degrees. Then if you go to the class B pulley, as you can see, we are having a class B. From edge, the top edge to edge, it will be measuring 17 or 16.5 millimeters. Then the depth will be 13 millimeters. The depth from the top of the face to the bottom, that is the depth. That's what I mean by the depth. It will be measuring 11 millimeters. Then the inclination angle still will be 40 degrees. So the inclination angle doesn't change. It's 40 degrees whether A, B, C or D. The inclination angle is always 40 degrees. A class C pulley, the dimensions, it will be 22 millimeters from edge to edge. I don't have a C class pulley, but I can give you a picture. From edge to edge, for it will be measuring 22 millimeters. Then the depth will be 14. Then if we are to talk about the inclination angle, it will remain 40 degrees. Then a class D, it will be measuring 32. Then it will be measuring 19 to the depth. 32 edge to edge, the 19, the depth. Then the inclination angle will be still 40 degrees. So basically, those are the sizes to the different classes of the pulleys. We talked about the A, the B, the C, then D. So if you want to verify the class according to the measurements, they might vary, but the variation shouldn't go beyond 1 millimeter. If we talk about a class B, it could be 16.5, it could be 16, it could be 17. It it would be a class B. Class A, it would be 13 or it could be 12.5, but the range of, or the tolerance shouldn't go beyond a millimeter of that specific class. So basically those are the different classes of the pulleys and the different sizes in the perspective of the different classes actually. So basically those are the pulleys, the classes, the classification, what they are, what they do. With all said, I hope now you get a clear picture of what a pulley is, what it's used for, the different types, and where we apply them. I remain Isaac from the Innovation Consortium. Thanks for watching. You just keep tuned in. We are still bringing more of the episodes of How To. Thank you very much.